Okay, today we're going to go over the area bounded by two polar curves. It's quite simple, so we might as well get into it. The equation for the area bounded by two polar curves is A, which equals 1/2 the integral from A to B, and B being values of theta, r squared minus r squared d theta. Now, both the smaller lowercase r and the larger capitalized R just represent the functions for two separate polar curves. Now, these power reducing equations down here aren't related to polar in general, but you're going to come across it a lot. So it's important to memorize. That's it for the equation. Okay, one thing I forgot to mention is that in order to find A and B, the theta values that are going to act as the bounds for your integral, you're going to want to set both curves equal to one another. So we're going to say up here, let cosine theta equal 1. And whenever you're equating something on an AP test, I've always found it useful to say that you're letting the two equations equal one another. So when does cosine theta equals 1? When does cosine theta equal 1? When theta is equal to pi, 0, or 2 pi. Now in this case, we're only going to focus on 0 and 2 pi. I'll show you by sketching out the two curves here. Let this circle over here represent r equals 1, and let this one over here represent cosine of theta. And you'll learn why once I eventually post a video on how to sketch polar curves. But the way polar integration works is by it sweeps based on the angle. So it's going to start here at angle theta equals 0, and it's going to sweep until it reaches over here, which is going to be angle theta equals 2 pi. And truthfully, these are the same thing, except in polar calculus, they're treated a bit differently. But that doesn't matter right now. Well, I suppose it does. But yeah, that's the reason why we're focusing on 0 and 2 pi. So let's set up our equation. Let's just give the general term first. A equals 1/2 from A to B of r squared minus the r squared for the other curve d theta. Now we could fill this in. A equals 1/2 from 0 to 2 pi r squared, which in this case is going to be cosine theta. So we might as well say cosine squared theta, minus the other r squared, which is just 1 squared. So that's just 1. Now, if you recall, I just taught you the equations for power reducing with trig functions. So cosine squared theta is actually equal to 1/2 1 plus cosine 2 theta. This is important to know. You got to know this for polar integration. And I admit that polar itself doesn't show up that often on the AP exams. Thank God. It's one of my least favorite subjects in calculus, but it will occasionally show up, and so you do need to know this. So let's simplify. Let's find the antiderivatives of some of these terms. So, well, first let's simplify. So A equals 1/2 the integral from 0 to 2 pi of 1/2 1 plus cosine 2 theta minus 1. Now let's distribute this 1/2. So we end up with 1/2 plus 1/2 cosine 2 theta minus 1. Now we can simplify this further by combining 1/2 and 1. And so we end up with, or our integrand is now 1/2 cosine 2 theta minus 1/2 d theta, of course. Now we can find the antiderivative. So we're going to say that A equals 1/2 times the antiderivative of each of these. The antiderivative of 1/2 cosine 2 theta is, I believe, 1/4 sine 2 theta. Now we can prove this by just taking the derivative of this over here, and we can see that it is indeed equal to 1/2 cosine 2 theta. Minus the antiderivative of 1/2, which is just going to be 1/2 theta, since we're integrating with respect to theta, from 0 to 2 pi. Okay, now let's see if I want to simplify this or not. A equals 1/2 times 1/4 sine 4 pi, which is just going to be equal to 0. And so we might as well just get rid of that term entirely. Minus 1/2 2 pi. So minus pi, I suppose. Minus 1/4 sine 0. However, that of course is equal to 0 because sine 0 is equal to 0. Minus 1 over theta here. Theta, we can substitute 0 in for theta, which is equal to 0. And so our true term is 1. Our true final answer for the area bounded between the curves r equals cosine theta, r equals cosine theta, and r equals 1 is negative 1/2 pi. Okay, so this question is a bit more difficult than the one prior. We're going to start off by setting the functions of each equal to one another to see where they intersect. So we're going to say that sine theta is equal to 3 sine theta is equal to sine theta plus 1. Now we can subtract sine theta from both sides and divide each side by 2. So we end up with sine theta equals 1/2. And if you've memorized your unit formula or unit circle, then you'll know that theta equals pi over 6 and 5 pi over 6. So there's going to be parameters for our integral. So the formula for the integral is a equals 1/2 the integral from a to b r squared minus the other r squared d theta. And from here we can just fill in the blanks. A equals 1/2 5 pi over 6 to 5 pi over 6 of 9 sine squared theta minus sine theta plus 1 squared d theta. Now let's first simplify this this term over here. So this is going to be simplified to sine squared theta plus 2 sine theta, plus 1. And we might as well simplify this sine squared theta while we're at it as well. If you'll recall, it is actually 1/2 1 minus cosine 2 theta. And we might as well simplify this one over here as well. And we will include the constant. So we're going to end up with 9 over 2, 1 minus cosine 2 theta. From here, we just need to take the antiderivatives. So a equals 1/2 times what is about to be inside this sort of these brackets. So the antiderivative of 9 over 2 minus 9 over 2 times 1 minus cosine 2 theta is going to be 9 over 2 theta minus 9 over 4 sine squared theta. And if you have trouble seeing why, then just take the derivative of negative 9/4 sine 2 theta, and you'll end up with negative 9 over 2 cosine 2 theta minus 1/2 theta. And since we're subtracting this, it might as well be a plus. Plus 1/4 sine 2 theta. God, this is getting a bit confusing. Minus, I should say. At this point, we're taking the antiderivative of this term over here. So we end up with minus 2 cosine theta plus theta from pi over 6 to 5 pi over 6. At this point, we've almost finished everything. I had to erase a bit since it's been getting a tad bit crowded. We just have to fill in the blanks here. I won't simplify because I don't believe I'm smart enough. So we can finally say that a is equal to 1/2. God. 9/2 times 5 pi over 6 minus 9/4 sine 5 pi over 3 minus 1/2. Sorry, 5 pi over 12. That's what I meant to say. You simplify it a little bit. Plus 1/4 sine 5 pi over 3 minus 2 cosine 5 pi over 6 plus 5 pi over 6 minus 3/4 pi minus 9/4 sine pi over 3 minus 12 pi over 12 plus 1/4 sine pi over 3 minus 2 cosine pi over 6 plus pi over 6. And that is our final answer. That is the value bounded by the two curves, 3 sine theta and r equals sine theta plus 1.